So in this video, you're going to learn about linear equations. Linear equations are equations that have a y and an x both to the first power and that determine a line. So any linear equation will result in a line when you graph it on a coordinate plane. So you're going to learn how to figure out what points are going to be on your line by doing an xy chart, which is very similar to what we did when we did constant of proportionality. We're also going to learn how to take those points and graph them on a coordinate plane to make sure that they do in fact draw or connect to be a straight line. So on this slide, you're looking at two equations that are called linear equations. These are called linear equations because they have a y and an x, and both the y and the x are to the first power. These should be familiar to you because you've seen equations when we were doing constant and proportionality equations. And now we're going to look at how to do all linear equations, even when there isn't a constant of proportionality involved. Our first step is going to be to make what we call an XY chart. And the XY chart is going to have X on the left and Y on the right, or it could have X on the top and Y on the bottom. So again, this also should look familiar to you from when we were doing constant of proportionality. You're going to choose your X values and you're going to get out Y values in return. So you're going to choose your inputs. I usually choose 0, 1, 2. Maybe I'll throw a -1 in there. I'm going to ask that you do 4 points, maybe 5 points, definitely more than 2. And you'll see why you're going to want to do more than 2 when we start graphing these on coordinate planes. So I'm going to stick 0 in for X. And I'm going to happen to get 0 out for Y because 2 times 0 is 0. And then I'm going to stick 1 in for X. And when I do that, I get that Y equals 2. And when you start noticing the pattern, you can end up just filling in. Or you can keep going and say, okay, I'm going to stick 2 in for X and get 4 out for Y. I'm going to stick -1 in for X and I'm going to get -2 out for Y. What you should be noticing here is that you have an X value and a Y value for each of your equations, for each of your points, and that the X and the Y should start looking to you like coordinates. So right now you have 0, 0, you have 1, 2, you have 2, 4, and you have -1, -2 as 4 points. When you plot these points on a coordinate plane, you're going to get a completely straight line, which will be modeled for you in a little while in this video. So if I look at this, I'm going to notice that y equals 3x minus 2. So I'm going to do an xy chart. And I'm going to pick 0, 1, 2, -1. I can pick whatever I want. Those are my favorite numbers, and I'm going to plug it in. So y equals 3 times 0 minus 2, 0 minus 2. So y is going to equal -2. If I plug 1 in, 3 times 1 is 3. 3 minus 2 is 1. If I plug 2 in, 2 times 3 is 6. 6 minus 2 is 4. 3 times -1 is -3. -3 minus 2 is -5. So again, now I have 4 points, which are 0, -2, 1, 1, 2, 4, and -1, -5, which if I plot on a coordinate plane will give me a straight line. So here are the points plotted from the XY chart of y equals 2x. What you've noticed is I've labeled these points, which you don't have to do, but what you do have to do is label the line. Most of the time we label the line by writing it right on the line, but you could also write it right above the line. So what you see now is that all 4 of the points that I have plotted connect to be a straight line. The important part of doing more than 2 points is that if you happen to make a mistake, you'll notice because your point will be somewhere that's not necessarily in a straight line from the other points, and you'll know that you did something wrong. So I want to make sure that I model for you what happens when there's a negative coefficient, which is absolutely nothing different, and a fraction. And the fraction's important because we're going to strategically pick our x values. Again, I pick 0, 1, 2, -1. I could always put the -1 first. You don't have to. -3 times 0 is 0, plus 1 is 1. 1 times -3 is -3, plus 2 is -2. So if I'm going too fast for you, all I'm doing is substituting the number in for x and getting an answer. That should be -3. 2 times -3 is -6, plus 1 is -5, and -1 times -3 is +3, plus 1 is 4. So again, I would take these points and I would plot them on a coordinate plane, and I should get a completely perfectly straight line. It's going to have a diagonal or a slant to it. Some of the lines are going to be going so the tip of the line faces the upper right-hand quadrant, quadrant 1, and others will be going towards quadrant 2, and we're going to talk about that in another time. When you have a fraction, it's important to strategically pick your x values by picking x values that are divisible by the denominator. So in this case, we're 1/2, so I'm going to pick numbers that are divisible by 2, and so therefore I'm going to go up by 2's. I could do -2 or I could do 6. That's my choice. It should determine the same line. It's just going to be different portions of the line. So 0 times 1/2 is 0, -2 is -2, 1/2 times 2 is 1, -2 is -1, 1/2 times 4 is 2, -2 is 0, 1/2 times -2 is -1, -1 minus 2 is -3. So again, I would take these points and I would plot them on a coordinate plane. So I've just shown you 2 more examples of taking the coordinates that you got by choosing your x values and getting out your y values, plotting them on a coordinate plane and connecting the dots. So again, you should make sure to label your lines, make sure you pick at least 3. I would prefer 4 x values to get out 4 y values, plot those points, and make sure you label your coordinates. I know that I didn't in this video, but you should, just like all the other graph details, you should be having 1, 2, 3, and -1, -2, -3. It's just really hard doing that on such small coordinates, on such small grids.